So we'll find the derivative of sine theta using the definition of derivative. So we know that derivative of function is the limit as h goes to 0 of the function evaluated at x, which in this case is theta, plus h, minus the function evaluated at x, or theta, all divided by h. Now, in the numerator, we have difference of two sine functions. I don't know any good identities to help simplify that. But here I notice we have a sum inside of the sine function. We do have an angle sum identity that can help us with that, which hopefully you learned in pre-calculus, but I'll remind you of it now. So this will be the limit as h goes to 0. H goes to 0. When you have a sum inside of sine function, you will get sine of the first term times cosine of the second term plus cosine of the first term times sine of the second term. And then don't forget this right here, so we'll still have minus sine of theta, and this is all divided by h. By the way, this right here means cosine of h, not hyperbolic cosine, for those of you who might know what that means. Alright, now let's take a look at these two terms. Notice we have a common factor of sine of theta, so I'm going to factor it out. I'm also going to kind of break up the limits here. Limit as h goes to 0. So we have sine of theta times cosine of h minus 1. And I'm going to go ahead and put this as over h. Then I'm going to take care of this term over h in another limit, because when you have a limit of a sum, you can write that as the sum of two limits. So this one here will be the limit as h goes to 0 of cosine theta sine of h over h. Now let's take a look at this here. Here we have a sine of theta, and here we have a cosine of theta. Notice that our limits are in terms of h. H is the variable. So we have theta acting like a constant. So sine and theta and cosine theta are really just constant multiples that we can bring out to the front of the limit, because they don't change the limit. So this will be sine theta times the limit as h goes to 0 of, so now we have left in the numerator just the cosine h minus 1. And this is still over h. And then for the second term we have cosine h times, well actually, cosine of theta, not h, times the sine of h over h. And I have to do that over because I forgot to put down limit times the limit as h goes to 0 of sine of h over h. Alright, now let's see if we can clean some of this up a little bit here. So firstly, limit as h goes to 0 of sine h over h. I have a video dedicated to that. So if you haven't watched it, you should probably stop watching this video and go watch that video, so you will know that this is equal to 1. So basically here we have cosine theta times 1. Multiplying by 1 doesn't change anything, so I can cross this whole part off. Now we have to figure out this limit. This is the harder one. So what I'm going to do is save this, and I'm going to make a new screen so we don't get too confused here. And we're just going to try to figure out this limit right here, and then we'll go back and apply it. So we're trying to figure out the limit as h goes to 0 of cosine h minus 1 over h. Now, whenever I see this cosine h minus 1, any trig function minus 1, or 1 minus any trig function, or 1 plus a trig function, I think about multiplying by the conjugate, because that'll let me use some Pythagorean identities for the trig function. So let's take a look at that here. So I'm going to take a look at this fraction here, and I'm going to multiply top and bottom by the conjugate of the numerator, which will be cosine h plus 1 over cosine h plus 1. That's right, in calculus we rationalize the numerators. So on the top here, cosine h minus 1 times cosine h plus 1. Well, hopefully by now you recognize that as difference of two squares factorization. So if you multiply that out, you'll get the square of the first term minus the square of the second term. And I'm not going to distribute the denominator, I'm just going to leave it as how it is. Should put an equal sign here. Alright. I don't know what cosine squared h minus 1 is. I don't have a good identity for that. But I do know what 1 minus cosine squared h is. And 1 minus cosine squared h is just the opposite of sine squared h. So I can factor out a negative here. This will be the limit as h goes to 0 of the negative, this is the negative of 1 minus cosine squared h here. And then this is still over h times the cosine of h plus 1. And this negative sign right here is a constant multiple, so I can put that in front of the limit sign. So this will be negative limit as h goes to 0. 1 minus cosine squared h. Well, the Pythagorean identity tells me that sine squared h plus cosine squared h is equal to 1. So you just subtract cosine squared h from both sides, you'll get 1 minus cosine squared h is equal to sine squared h. And I'm going to write that as sine of h times sine of h. And then this is still over h times cosine of h plus 1. Now, let's break this up. I'm going to take a look at this. I'm going to think of this as sine h over h times sine h over cosine h plus 1. And when you have a limit of a product, you can break it up into a product of two limits. So for the first part here, we will have the limit as h goes to 0 of sine h over h. And then we will multiply this by the limit as h goes to 0 of the second factor here, which will be sine of h over cosine of h plus 1. Alright, now, let's see if we can clean this up a little bit. Limit as h goes to 0 of sine of h over h. Well, we know what that is. We just used it. This is equal to 1. So we have 1 in this product here. So multiplying by 1 doesn't change anything. Now we just have to figure out the limit as h goes to 0 of sine h over cosine h plus 1. And as it happens, this function is continuous at 0. We can actually plug in the 0. So we have still this negative sign in the front. So plugging in 0 here, we'll get on the top sine of 0, which is 1, which is 0, over cosine of h, which is 1, and then we still have the plus 1 right here. 0 over 2, even with the negative in front. That is still 0. So we've figured out what our limit that we needed to figure out. So now I'm going to go back to the other slide. So we just figured out that this limit is equal to 0. So multiplying by 0 means this whole term gets knocked out. So all we have left is this little guy right here, cosine of theta. And that is the derivative of sine of theta.